This video is going to go over how to answer questions about the derivative of a graph, so the maximums, minimums, points of inflection, even intervals of increase, decrease, and concavity, using our TI-84, so calculator questions. So given a problem like this, the first thing I want to do is go to y equals and type it in. And in some of the newer calculators, it's actually a little bit easier to type these in. In my old school calculator, I have to use all of these parentheses and make sure that I have that whole exponent in the parentheses. And then I need my cosine. And notice how the x is the only thing in the argument of this cosine. If the 6 were meant to be within it, there would be parentheses. So the fact that we don't have parentheses tells us it's just going to be the x in there. So then I want to actually put my derivative in. So I'm going to go math 8, because everything that we can do to answer this question we can do with the first derivative. And again, in the newer calculators this looks slightly different. It's a little more straightforward. You want to have dy dx, y1 would be in the parentheses, and x equals x on the right. So now we actually don't need our original function, we're just going to use the derivative here. So I'm going to turn it off by going up to the equal sign and hitting enter to turn that piece off. So we only need the derivative. And then I'm going to go to window, because our problem actually gives us the window for the x values. So in my x minimum, I want -1, and in x maximum, I want +1. If your problem gives you a window, you must put that in your window. Otherwise, you're going to see way too much or way too little, and it's just going to change the whole problem. The next thing I want to do is turn my x res up to 3, just so it graphs a little bit quicker, because when we do derivatives, it can take forever to graph. So I've got my window there, I've got my x res, I'm going to click graph. And we can see a little bit here, but it is really kind of tough to see what's going on because it's so zoomed out in our y values. So what I think we should do is change our y minimum and maximum to like -2 and +2, because I think that'll let us see enough of this situation. So I'm going back to window. I'm going to change my y min and y max to -2 and +2. And now we can see a lot better what's going on here. So this looks great. So a maximum is going to occur when our derivative, because remember this is the derivative, changes from positive to negative. So the maximum on f of x will be at this piece right here. So if I need to find an x-intercept, I'm going to hit second trace 0. 0 means x-intercept, and you can either click 2 or you can click enter when you go over there. So now this is telling us left bound, question mark. So what we need to do is I'm really trying to find this point right here where my x-intercept happens, where it changes from positive to negative. So I need to go to the left of that just by a little bit. So my cursor now is definitely on the left of this x-intercept. So I hit enter. Then it tells me to go to the right bound. So I need to move to the right of the x-intercept and then hit enter. And you should see these little arrows, or in the fancier calculators, the lines that tell you that the calculator is only looking between these two places. And then it asks if you want to guess, and we just hit enter. We don't need to guess. And it says R0 is at 0.3659. And remember, we always want to round to 3 decimals. So 366 looks good. Let me check that one. All right, we got that one. So the next thing we want to do is find the minimum. So if a maximum happens when the derivative goes from positive to negative, a minimum happens when our derivative goes from negative to positive. So that's over here. So again, we need an x-intercept. So I go second trace, 0. And again, it's going to ask me for the left bound. So I need to move to the left of that x-intercept and hit enter. Then I'm going to move to the right and hit enter. And then instead of guessing, just hit enter. So the 0, the x-intercept, is at -0.365, because we round to 3 decimals. That looks good. That is where it switches from negative to positive on the derivative graph, so that's a minimum on our original graph. All right, next up we want points of inflection. So it looks like there's going to be two, and if we look at this graph we can see there's one up here and one down here, because remember, a max or a min on your derivative is going to be a point of inflection on the original. And really it's not technically that it's max min, it's really that it goes from increase to decrease, so that switch in slope, or from decrease to increase. So now instead of a 0, I want to find this maximum point up here. So I'm going to hit second trace again, but instead of 0, maximum, number 4. And I want to be on the left of the maximum, and it looks like the max is right about here, so I'm definitely on the left. Hit enter. Then I need to go to the right of it, so I want to be for sure to the right. That's definitely on the right. I feel good about that. And we don't want to go too far so that you could get multiple maximums. This is plenty of space to narrow it down in here. When I hit enter a third time, it says our maximum is at 0.082 if we're rounding to 3 decimal points. All right, looks good. And now our last point of inflection is going to be this minimum. So I go second trace, and instead of 0 or max, I want a minimum. So I'm going to follow the same kind of instructions, be on the left of the minimum. So here's my minimum, definitely on the left, hit enter. Then I need to scroll so that I come back up, and I'm definitely on the right, hit enter. You can see my arrows are definitely surrounding this minimum, hit enter again, and our minimum x value is 0.687. All right, so we got them all right. So now if our question were asking about intervals of increase, decrease, or concavity, these are really the important points that we would use. So if the question were like, where is this function, the original function, decreasing, that would be where the derivative is negative. So that'd be between -1, because our window, until that first x-intercept, -0.365. And then also again from 0.366 until +1. If it asked where is it increasing, that'd be between our x-intercepts, so between -0.365 until 0.366. So this is how we use our calculator to answer questions about derivatives.